quadratic forms. So you have dealt with quadratic equations, maybe when you're in what? Grade 9, 10, something. At the very most, 11. But I'm sure before that. This is the vector matrix version of that. F of x, so we have multiple variables, x1, x2, x3, and so on. It's given by this, and these are the coefficients. This is a quadratic term, okay? And this is a linear term, summation pi xi. We can rewrite this in this manner, where q is equal to this. Okay. P transpose x is the same as x transpose p, remember that, right? The gradient is half q plus q transpose, because q might not be a symmetric matrix. So q and q transpose, you have to consider x. See, what's the scalar equivalent of this? Half qx squared, right? This is P transpose x. The derivative, this is the linear term, first order term, P transpose x. Always remember when you do this differentiation, the derivative, the gradient has to be a column vector. P transpose is a row vector, right? So you have to take the transpose, so it's a column vector. And the Hessian is simply half of q plus q transpose. Now, 99% of the cases, in real world and any application, Q will be a symmetric matrix. Okay. In which case, when Q is symmetric, then what happens? Q and Q transpose are the same, right? Q transpose equals Q. So this reduces, the gradient reduces to half of q plus q is q, right? So qx plus p, this is the gradient. And the Hessian becomes q. Always remember this, okay? If you're given a quadratic expression like this, then the first derivative is this, and the second derivative is this. And now what happens is, why do I assume that Q is symmetric? Because if suppose you're given a Q that's not symmetric, okay, you can replace this Q with half of Q plus Q transpose, and you'll get the same value. Okay. So I have written something like that in the lecture notes. Q sim and Q skew symmetric. Q minus Q transpose is a skew symmetric matrix. Okay, just go through that and you'll understand. It's very simple. Okay, so quadratic form, just memorize this. Okay, it's easy. Okay, differentiating quadratic function. So this is, we're given this. And if we simplify it, we get this function. This is a scalar form. Okay, this is the same formula in terms of matrices and vectors. So this is, f of x is, this is q, this matrix that I've colored red, and this is P, or P transpose, since it's a row vector. Okay. So we can take the derivative like this. We can just differentiate this, and we get this.